Okay, so we're ready for our second and final example. And let me read it to you. So this is going to be to show that the equation 4 plus natural log of x plus 2 equals x squared has a solution in the interval 2 to 3. Now before we get going on this, I do want to comment to follow up on our discussion about calculus versus algebra. This is kind of maybe a pre-calculus type equation here, so lumped in with the algebra side. We could just try to solve this for x. Now, I welcome you to try that, and you can try all your techniques in the world you have on this, and there's not going to be a sort of pre-calculus way to solve this equation for x. So basically, this is where the algebra fails, so we're forced into something different, forced into doing something like the calculus using the intermediate value theorem. Okay, so what I want you to do is go ahead and pause the video now and try this one on your own, and then we'll come back and work it together, right? So please go ahead and pause this, do all of your work, write it down, and then follow along after you unpause it as I do the solution. Okay, so let's check out and see how this goes. We kind of know the process now. We need to rewrite this in the correct form, this equation, function equals number, because right now it's in function equals function form. Now I'm going to maybe write it in a different way than you did. I'm just going to subtract the x squared from both sides. So let's see, we'll do 4 minus x squared plus ln of x plus 2 equals 0. Now, of course, another natural way to rewrite this would have been to subtract the ln of x plus 2 from both sides. Then you get a number 4 equals a function x squared minus ln of x plus 2. And again, either one of those ways will work. In each way, you'll have a different function f and a different capital N. But in that next step, you'll still be able to show that capital N is between f of a and f of b. So the IVT will give you the conclusion. All right, so I'm going to use this rewrite. Now, of course, with this rewrite, my function f of x is this function, 4 minus x squared plus natural log of x plus 2. And of course, my capital N is the number I want the function to be equal to, so capital N is 0. My a and b come from the problem. They're the x values that we want the solution to live between. And so those x values are 2 for the smaller one, a, and 3 for the bigger one, b. Now we have to think about that first condition that we're checking in the IVT. How do we know this is a continuous function? How do we know f is a continuous function? Well, it's built from familiar continuous functions, so it's going to be continuous on its domain. No problems with domain in the 4 or the minus x squared. We can use anything for x in that part. But when we look at the natural log, remember you can only take a natural log of positive numbers. So we can only take a natural log of something that's bigger than 0. So the domain here requires x plus 2 to be bigger than 0, and that happens when x is bigger than negative 2. All right. So we'll sum all this up in the following way. The function f of x equal 4 minus x squared plus natural log of x plus 2 is continuous on its domain equals negative 2 to infinity. So f is continuous on the closed interval 2 to 3, which sits inside of this domain. And being continuous on that closed interval is really what we wanted, right? So here f is continuous on this closed interval 2 to 3 is what we wanted for that first condition. Now for the second condition, we've got to calculate f of a and f of b. And for us, that's f of 2 and f of 3. So we need f of 2 and f of 3. Okay, so f of 2 is 4 minus 2 squared plus natural log of 2 plus 2. And now that's going to come out to some infinite decimal because natural log of 4 doesn't simplify or anything like that. But if you put it into your calculator, what you see is it's going to be approximately 1.386. And since it's approximately 1.386, that'll be good enough for our purposes. F of 3 is 4 minus 3 squared plus natural log of 3 plus 2. And again, natural log of 5 does not simplify. And so all we can say is that this is approximately equal to negative 3.391. So we calculated our f of a and f of b. Now we have to verify that capital N is between f of a and f of b. And so for the way we chose f, capital N has to be 0, what we want that function to equal. And so what we see is we've got to compare both of these to 0. And so clearly this number is positive, and this number is negative. And so 0 is between those two because it's less than this one, but bigger than that one. All right. So here, we've done the work of checking that second condition of the IVT. Okay, so now, since we've checked the two conditions, we're going to say that we're using the IVT. Very importantly, I'll be looking for that when I'm grading. You'll say something like, by IVT, there is a number C between A and B, so for us that's between 2 and 3, between 2 and 3, such that f of c is equal to n, and so for us n is 0, such that f of c is equal to 0. Now, of course, that c is the desired solution. So c is the desired solution, and we're done. We've shown that there is a solution to this equation between 2 and 3. Okay, so that's the examples that we'll do for intermediate value theorem, and I'll post some homework problems for you to work on. Some of them will be examples like this. Some of them will be more kind of thinking examples for you to figure out how some things work with this intermediate value theorem to make sure you're understanding all the parts that go into this. Okay, sorry we couldn't do this in person, but I'm glad that this great technology is allowing us to push ahead after missing a couple days last week. All right, so look forward to seeing y'all next week, and make sure to work on this homework before Wednesday. Okay, thank you.